Hello, this is a short video on freefall. Just one slide, actually, with a bunch of points about the concept of freefall. It's a special type of constant acceleration motion. And what I have here are some pictures of an experiment that you'll probably see in class. But it's a penny being dropped and a feather being dropped together. And they're inside this tube, and the tube is at normal air pressure, though. And when they're dropped, they fall differently. The penny drops in a way that if I drew a motion diagram, it might look something like this. It's getting faster as it falls. The feather could have a motion similar to this blue motion map over here. It'll probably kind of like flitter and float and kind of fall downward erratically. But the penny will definitely hit before the feather does. And the reason this happens is because the penny itself is traveling through the air with less hindrance than the feather is. The shape of the feather and the fact that it's very light, it doesn't have much mass, both are affecting the motion as it falls. If you could evacuate the air out of this container, if you could attach an air pump to it and take all of, well, not all, but a vast majority of the air out of this container, and then repeat the experiment, you would find that the penny and the feather actually fall together. This experiment was done on the moon by the astronauts with a hammer and a feather that they brought with them for dramatic effect. But what we are seeing here is that if you can get rid of the effects of air resistance, that all objects, regardless of their mass and regardless of their shape, should fall with the same acceleration. And that acceleration you can get from doing an experiment like we'll do in class. It ends up being 9.8 meters per second squared. So an object in free fall, and that means that the object is only under the influence of gravity. Right? It doesn't literally mean the object has to be falling. An object in free fall can be an object that you threw up into the air, and its motion upwards and then back downwards is all called free fall motion. But the acceleration of every object in free fall is 9.8 meters per second squared downwards. So quite often in these problems, we make down in the negative direction. So a lot of people see this as the acceleration in free fall is equal to negative 9.8 meters per second squared. Sometimes you see 9.81, people will throw another digit on there, but 9.8 is fine. So here are some important points that I just added on here, and if you read through the chapter and take a look at the problems we do in class, you'll eventually pick up on these. But free fall is a motion for an object that is only under the influence of gravity. Free fall does not only mean falling, as we said, it could also mean the motion of an object that's traveling upwards, but is only under the influence of gravity, so the object would be getting slower. The way that would look is if you threw an object upwards with some initial velocity, vi, it's going to get slower as it goes up, so the velocity will decrease. The amount that it changes is 9.8 meters per second squared. 9.8 meters per second each second. So as the object gets slower and slower, eventually it will stop and then turn around and fall back downward. Even at this moment where the object has a velocity of 0, its acceleration is still negative 9.8 meters per second squared. Remember, acceleration doesn't tell you how fast an object is moving. It tells you how this velocity number is changing. So even when the velocity is 0, it's in the process of changing. So there's an acceleration. So the free fall acceleration is 9.8 meters per second squared, even if the object is going upwards. The free fall acceleration is 9.8 meters per second squared downward, even if it comes to rest at its maximum height when that happens. In reality, all objects do encounter some air resistance, and using 9.8 meters per second squared is really an approximation. But that's what science is all about. A model does not account for everything, and using it has limitations that you and your audience should be aware of. Some important tricks to remember when problem solving with free fall, and we'll see these when we do some whiteboarding in class, that the phrase from rest or at rest means that the velocity is 0. When an object in free fall reaches its maximum height, it has an instantaneous velocity of 0. So if some problem asks you to find out information about the object when it reaches its maximum height, including what is its maximum height or what time does the maximum height occur, you're going to use that. They're not going to usually tell you this, but you should know that the velocity at that spot happens to be 0, the velocity in the y-axis. if an object is tossed upwards, it takes the same amount of time for it to reach maximum height as it does to fall back to the place from which it was thrown. And this is because of the position versus time graph symmetry. It's a parabola with even order symmetry. So in this particular motion diagram, when the object falls back towards Earth, it'll trace the same path over the same period of time as it falls back downwards. So this process repeats itself.